Today in this session, we will be studying about the air quality index, popularly known as AQI. Air quality index is a numerical value used to measure level of pollution in the atmosphere. Level of pollution in the atmosphere. It also communicates how clean and polluted air is. How clean and polluted air is. Based upon the air quality index AQI value, we categorize the atmospheric air whether it is good, moderate, satisfactory, poor, very poor, or severe. If the AQI is having range between 0 to 50, category is good. Air quality is clean and ideal for all activity. Likewise, if it is between AQI value is between 201 to 300, say the air quality is poor. The category is poor and air quality is also poor, and restrict earthwork, use water sprinkling, cover various etc. So 0 to 50 it is good, 51 to 100 satisfactory. If AQI value in between 101 to 200 moderate, if it is between 201 to 300 poor, 301 to 400 very poor, and 401 ever it is very severe. And accordingly, as an engineer, we decide whether sprinkling is required or we need to stop the work. So we often say a quality index displayed in the cities, like for some city it is 188. Finer particles are PM 2.5, finer particles which are very dangerous for the health. They mix with the blood and they penetrate into the lungs. So it is 80 microgram per meter cube, and the PM 10 it is coarser with the construction dust or cement industries. It is 123 microgram per meter cube. With this, we can decide whether this like 188 it is between 101 to 200. So moderate, but at higher side, moderately the air is moderately polluted. Increase monitoring, control dust and emission. When we find likewise whatever air quality index is displayed, with that we can decide uh, if it is very severe or poor or moderate or satisfactory or clean. So just by seeing one number displayed over the board, we can have the idea of the atmospheric pollution at that location. So in order to measure the air quality index, means in order to find out air quality index, we measure PM 2.5 of that location, particulate matter 10, sulfur dioxide, nitrogen dioxide, carbon monoxide, ozone, ammonia and lead. And based upon these the values in microgram per meter cube, we calculate AQI and then we display and we which one is the severe presence of concentration of say PM 2.5 is more, or PM 10 is more, or sulfur dioxide is more. Based upon that, we declare the air quality index of that area. So source for carbon monoxide, it is in complete combustion, traffic congestion in complete combustion. For nitrogen dioxide, vehicle exhaust is responsible. For sulfur dioxide, industrial stakes, PM10 generally with the road dust and excavation, and then PM 2.5 is construction dust, vehicle emission, biomass burning, etc. Carbon monoxide also with the incomplete combustion, and this ammonia is due to the agriculture activities. Ozone is a secondary due to burning this nitrogen dioxide when it comes with the VOC, uh, volatile organic compound, and with the sun, the ozone is produced, which is very harmful to the health when it is in excess. Any of them, when they are in concentration or excess than the limit, then only they are harmful to the health. So here also we can see one display where the PM10 is displayed 73, PM 2.5 55, sulfur dioxide is 7, ppm parts per million, nitrogen dioxides 15 parts per million, carbon monoxide 419 ppm, ozone 5 ppm. When we find the values in ppm, we should convert into the microgram per meter cube. This can be converted by ppm into molar mass of gas in gram per mole into 1000 divided by 24.45. Here we can see the calculation for ozone, which is in the atmosphere 5 ppm. So 5 into 48 gram per mole into 1000 divided by 24.45. So ozone in the microgram per meter cube 9815.95 microgram per meter cube. So we can see India Gate in Delhi. When the weather is clean, how it looks. When the AQI is approximately 200, it disappear, almost it disappear, and the atmosphere is very harmful to the health. So government take a lot of restriction to make the air clean, restrict the vehicular movement or drinking of water, etc. Written by the government of Delhi in this thing. It is due to also in combustion of the uh, this paddy, etc. When they burn in the Punjab, that also said to be polluting the air of Delhi. So there are many things, many factors responsible for this. So why is AQI important? When the value of AQI is low, the atmospheric air is clean, low pollution, safe to breathe. When AQI is high, polluted air, high pollution, high health risk. With the AQI help us to understand current pollution level, decide whether it is safe to go outside, and protect sensitive groups such as children, elderly people, and those with asthma and heart disease, pregnant women, etc. They are protected when we know their AQI is low or high. When it is high, these children, it is very harmful for the children, elderly people, those with the asthma and heart disease. So accordingly, they should not go outside the uh, outdoor. So this is unit should be for the measurement of PM 2.5, PM 10, SO2 and O2, O3 in a CPV so in microgram per meter cube. Then we find out the AQI, and once AQI find out, the highest sub index becomes AQI. If concentration of PM 2.5 is more than the PM 10, SO2 and O2, O3 and CPV, so AQI will be for the say for this if we got 150, for this 100 AQI value, for 180 likewise, then AQI will be 150 for that location. The highest sub index becomes AQI. So we have already discussed this. When AQI is between 0 to 50, the atmosphere category is good. When it is 51 to 100, satisfactory. If AQI ranges between 101 to 200, moderate. If it is between 201 to 300, poor. If it is 301 to 400, very poor. 401 to 500, severe. Then we measure the values when sulfur dioxide is between 0 to 40, AQI, it comes in the range of 0 to 50. Say if it has come 39, so then we find out AQI and for the 39 by applying this formula IHI minus I low upon VHI minus V low, the measured value minus VL0 plus I EL0. So likewise IPAQI subindex CP measured pollution concentration, BHI upper concentration, BHI is upper concentration, BL0 is lower concentration, B BLC here IPAQI subindex, IHI upper AQI breakpoint, upper AQI breakpoint say 200 for this, and IL0 lower AQI breakpoint, it is 101. In case of same sulfur dioxide, this lower concentration value is 81 and upper concentration value is 380. So to know the sub-index IP is equal to IHI minus IL0, BHI minus VL0, CP minus VL0 plus IL0. We input all this value and to get the sub-index means AQI of that that measurement what we received in the field. So we can see with the formula. We measured AQI for PM 2.5. Here we can say PM 2.5, 175.6 concentration of PM 25, 175.6, and concentration of PM 10 is 221.7. So we can know the sub-index IP means AQI value for this. So IP will be I HI minus IL0 divided BHI minus VL0 measured value CP minus VL0 plus IL0. Here IHI is 400, IL0 is minus 301, BHI is 250, you can see here, BHI is 250 for PM10, BHI is 251 for PM10. So here we are calculating for the PM 2.5. So for PM 2.5, the value is between, this is 175.6, 175.6. So value is between 121.50. So BHI will be 250 and BL0 will be 121. Accordingly here IHI will be 400 and lower the point is 301. So this value we are presently taking into the consideration. So 250 minus 121, measured value is 175.6, 175.6 minus 121 plus 301. IL0 is 301. So we can calculate this. So it will become 99 divided by 250 minus 121 is 129. 175.6 minus 121. 175.6 minus 121. 54.6 plus 301. So 99. We can 99 divided by 129, it is 0.76 into 54.6 into 54.6 equal to 41.90 plus 301 plus 301. So AQI value has come 342.90, 342.90. We can say 343 AQI index for PM 2.5 is 342.90. Likewise, we can calculate for the AQI value for the second concentration PM10, which is 221.7. For this, IHI is 201, 200, IH 221.7, 221.7. PM10 has come 221.7, means this is in this range. So for this, BHI is 250. BHI is 250 and V lower break point is 101 and when we see the AQI range 101 200, so this is I LI I IHI will be 300 and I low will be 201. So this value we can calculate for the PM10 also. We can calculate for the PM10 also. So for calculating PM10, here this calculation has come 343. For PM10, it will be 200 minus 101 IP for PM10. This IP is for PM 2.5. So and 250 minus 101. 250 minus 101. Measured value is 221.7. 221.7 minus 101 plus this is 101. So we can calculate for this also. 200 minus 101, that is 99. 99 divided by 250. 250 minus 101 equal to 250 minus 101 equal to 149. 221 minus 101, directly we can say 120.7 plus 101. 221.7 minus 101. 120.7 plus 101. So 99 divided by 149 equal to 0.66 into 120.7 into 120.7, 80.19, 80.1 plus 101 plus 101. So AQI has come 181. AQI has come 181, which is lower than. So the highest value is for the PM10, which is 343, and for this it has come 180. So 343 is greater than 180, hence AQI for this location will be, AQI displayed will be 343. Likewise we calculate for the sulfur dioxide concentration, for the nitrogen dioxide concentration, for the ozone concentration. So all this we measure in the atmosphere with the stable IS code, and then we bring it to the laboratory. We bring the sample in the laboratory, test it, measure the values, and then convert into the respective AQI, and whichever is the greater value or highest value, we declare as a air quality index of that location of the air. Thank you.